So this is on the refreshed wrapper for XGBoost. So for anybody who's not already aware, XGBoost is a really popular C++ machine learning library for mostly gradient boosted trees, gradient boosting in general. If you've done much machine learning, you've probably heard of it. Has wrappers in just about everything. I'm not going to try to explain what gradient boosting is here, but essentially the idea is that at each iteration you train a correction to your previous model. You wind up having to minimize this objective here, which depends on the first and second derivatives of the loss function. So if you have those, you can use a custom loss. So a lot of people have been working on this wrapper recently. It's sort of been an explosion of interest. Tyler Thomas, I don't think I've seen him around, but he did a lot of the binary builder stuff that needed to be done, especially for CUDA, stuff like that. Avik, I think, was one of the maintainers of the package originally. David Widman, I think he did the now CUDA and Term are lazily loaded extensions in 1.9, and others have provided a lot of helpful commentary for things to get merged. Jiaming Yuan, I think he is from the main XGBoost repository, so it's been nice to hear from them. So just quick sample of its usage, very straightforward. So when you call XGBoost, it returns this model object, which contains the entirety of the model, which you could use to run predictions. And you could get some useful introspection out of it, such as importance reports. You could get this as an actual table as well as a nice term display there. You can also, well, I got slides specific on the features, so I'll move on to those. I rewrote this wrapper at some point. It's actually been around for quite a while. So now it uses an automated wrapper of libxgboost from Clang, which is maybe not so much useful for users, but very useful for development on the package. Everything is fully Tables.jl compatible. It can track parameters, feature names. The feature names is actually a really useful thing because if you're looking at the trees themselves, it's useful to know what feature is being split on, that sort of thing. That stuff had to be done in the wrapper itself because it's not supported in the C library. There's support for GPUs via CUDA, which again is lazily loaded now. Some nice terminal output via term.jl, which makes these kind of nice, pretty term displays that you saw there. It does support custom loss functions. For the time being, it requires you to provide the first and second derivatives yourself. Again, feature importance. The trees themselves are compatible with AbstractTrees.jl, so you could do some pretty generic stuff with them, which is nice. There's some default parameter sets there for different types of regressions, classifications. Those were inspired by the MLJ wrapper package, which has the extremely elegant name MLJ XGBoost interface. So you can use it nicely from MLJ as well. I did want to mention real quick that there was, for a little while, this really terrifying bug in Windows that was preventing the libxgboost library from being loaded at all. Myself and some of the other maintainers didn't even have access to Windows, kind of had no idea what to even say about that. So big thanks to number of people, James Foster, Mark, who I believe is up there. I'm not even going to try to pronounce your last name. and Mose of Binary Builder fame, they came in and fixed that, which I can only imagine was, I'm sure the fix itself was just updating a library, but finding it, I can only imagine. So that's fixed now. So as of 1.9.2, you should be able to run it in Windows. If not, please, we closed the issue, so please report it if not. Some other features that'd be nice to have, I'd really like to have automatic loss functions. Like I said, right now you have to provide the first and second derivative. It'd be nice to do this automatically with some kind of, God knows we have enough AD functionality in Julia, so I'm sure we could find some, Zygote or something that should be pretty easy. So I think there's a very good chance that one of us will put that in. Categorical array stuff would be nicer to be a little more automatic. Right now it's a bit of a pain. There's some extra dependencies which are still can't really be gotten rid of. That would be nice when you not using CUDA. Tyler Thomas mentioned to me the multi-GPU support. I don't really know what's entailed in that, but it sounds interesting. We don't have CI/CD for GPU right now. It'd be good to have that so we could have proper tests. There are tests in the suite. You could do it locally if you want. I just wanted to mention real quick. I have nothing to do with EvoTrees here, but yeah, I've looked at it a little bit since XGBoost. It looks really nice. It looks just about. Again, most people are probably aware, but XGBoost is an extremely mature, popular library. So it's pretty cool that there's a pure Julia alternative that seems, I don't want to talk about their package for them, but I wanted to mention it, and it seemed like an appropriate place because I thought it looked nice. And that's it.
Does anyone have questions?
So I don't remember what is the status, but when you talked about these categorical arrays, it came to my mind, what is the current handling of missings if you don't use MLJ but directly wanted to use XGBoost.jl?
As in, what would it do if you tried to use those right now, or?
Columns that have missing values.
Oh, I don't want to speak out of turn. I vaguely remember, but I'm not confident in the answer to that, so I don't want to say. There are XGBoost does. I think it handles them correctly in that it leaves them out. It essentially doesn't use them when it learns the trees.
Package splits on missingness, so it uses them correctly. It doesn't mess them up, but it doesn't know what to do with categoricals at all.
Thank you for that. And I do believe, please open an issue if this is not true. I do believe the wrapper handles that. It's been a while since I looked at that, so I don't want to say something not true. But